Okay, so we have the continuous random variable x has cumulative distribution function f defined by these three different functions. So the cumulative distribution function is equal to 0 if you have x less than or equal to 0. It's defined by this function 2x cubed minus 6, x to the power of 6 in between 0 and 1, and f of x is equal to 1 for x greater than 1. Part A just asks us to work out what is the probability that x lies between 0.4 and 0.6. This can be done. Remember that when we're dealing with a cumulative distribution function and this capital F of x, that can calculate directly the probability. What we want to do is we want to find out the probability of x being less than or equal to 0.6, and then we're going to take away the probability of x being less than or equal to 0.4. So when we work through this, we're going to substitute in two lots of 0.6 cubed minus 0.6 to the power of 6, and then we're going to subtract the result from doing two lots of 0.4 cubed minus 0.4 to the power of 6. Now, when you work through that all, you can enter this into your calculator all in one go. There's no real marks for any further working out here. What we need to do is then give an answer, and I'm going to round this to 3 decimal places, so 0.261. Okay, so how are marks given in this question? Well, first of all, you're given a method mark simply for the statement, indicating that you know that to find this probability you can do cumulative f of 0.6 minus f of 0.4, and then you're given an accuracy mark after that just for working straight through and getting this answer of 0.261 or an equivalent when rounded. Okay, part 2 asks us then to find the median of x. So what we know is that the median is the midpoint, and it will be where the probability is equal to 0.5. So the cumulative probability up to the median will be 0.5. So we're going to just set up this equation, and so we're going to replace x with m. So I get two lots of m cubed minus m to the power of 6 equal to 0.5. I don't want a fraction in my working, so I'm going to times this by 2 to get rid of this fraction, so that I get 4m cubed minus 2m to the power of 6 equal to 1. And then when I rearrange that equation, we're going to get 2m to the power of 6 minus 4m cubed plus 1 equal to 0. Now, what you may or may not notice at this point in time is actually this is a quadratic in the term m cubed. What I mean by this is we could rewrite this as two lots of m cubed squared minus 4 lots of m cubed. Now I know that's not a massive difference, plus 1 equals to 0, but what you can kind of consider this to be is two lots of, let's just use another variable, a squared minus 4 lots of a plus 1 equal to 0, except a is actually m cubed. Now, I can't factorise this. 2 times 1 is 2. No factors of 2 will combine to give me minus 4. So what I'm going to do is I'm going to use the quadratic equation in order to solve this. So what I'm going to do when I do the quadratic equation is I'm going to say m cubed is equal to minus 4, so that's our b, plus minus the square root of minus 4 squared minus 4 times a, which is 2, times c, which is 1, all over 2 lots of a, which is 2. Okay, so when you work through this, parts of this can be worked out fairly quickly without a calculator, but you can put that into a calculator straight away. We can write this actually as 4 plus or minus, we get 16 take away 8, so it's plus or minus the square root of 8, all over 4. And so then when we work through this, you will find that m cubed can be, m cubed can be given as 1.707, or m cubed can be given as 0.293. Okay, now actually what I know at this point is that m has to lie between 0 and 1, so m cubed can't be greater than 1, it's got to be less than 1, so m is actually going to be the cube root of my second answer, which is less than 1, and so when I work through this, m is actually going to be 0.664 to 3 decimal places. Okay, so how do we get marks in this question? Well, first of all, you get a statement mark for this line here, just showing that 2m cubed minus m to the power of 6 equals 0.5. Then, if you can use a quadratic equation to work through to this point here, where m cubed is equal to m plus or minus the square root of 8 over 4, you can have a method mark and an accuracy mark. Okay. Finally, you have to then specify an answer, and you get the accuracy mark here. If you give both of them as an answer, you do not get your accuracy mark, so you must specify a valid value for m. Okay, so let's have a look at part B. Part B says find an expression for f of x valid for 0 less than or equal to x less than or equal to 1, where f denotes the probability density function of x. So what I want to do is I want to find the probability density function from the cumulative distribution function. In order to do this, what we need to do is f of x is obtained by differentiating the cumulative distribution function 2x cubed minus x to the power of 6. So this is part B, and so what we get is that little f of x is equal to 3 times 2, which is 6x squared, minus 6 times 1, which is 6x to the power of 5. And so quite simply here, what we're going to get the marks for is demonstrating that we method mark here for demonstrating in some way that you're going to differentiate, and you're going to get an accuracy mark for actually stating and getting the right result for differentiating and getting that probability density function. Okay, the final part of this question says we want to obtain, or we want to calculate the expectation of x cubed. Okay, so for part 2, in order to find the expectation of x cubed, what we are going to do is we are going to calculate between 0 and 1, that is the bounds that the probability density function is valid for, of the result of x cubed multiplied by 6x squared minus 6x to the power of 5 dx. Now, before we can integrate, we need to expand this bracket, but also notice that I've got this common factor here of 6. So to make life easier, I'm just going to take that 6 straight outside. I'll deal with that 6 last. So we get 6 times the integral of x to the power of 5 minus x to the power of 8 dx. So what I'm looking to evaluate is 6 times x to the power of 6 over 6 minus x to the power of 9 over 9, evaluated between 0 and 1. Now, when I work through this, I get 6 times, I'll put 1 in my upper bound, 1 to the power of 6 over 6 minus 1 to the power of 9 over 9. Take away, and just remember it's good habit to put in the 0. It's bad habit not to, and will lead to trouble later on in C3 and potentially sometimes, if you're not careful, in C2 and S1. Okay, so what we get is we're going to get 6 times this bracket once we evaluate it. So just use your calculator to evaluate this bracket. What we're going to get is 1/6 take away 1/9, and of course the 0 part does evaluate to 0, but we put it in for good practice just to make sure we don't make any silly mistakes. So what we get left with is 6 times 1 over 18. So it gives us 6 over 18, which is then equal to 1/3. So let's have a quick look at how we obtain the marks in this question. The first mark is for, the first 2 marks really is given for stating this line or this statement here. Okay, so method mark and accuracy mark here for stating that the expectation of x cubed is given for the integral, have to have the bounds on, of x cubed times this expression here. We are then given an accuracy mark for some arrangement of this value here, so essentially for the correct integration of our function with respect to x, and then you are given an accuracy mark for this final answer of getting that the expectation of x cubed is equal to 1/3. Okay, I hope that all made sense and that you understood it.